All right, thank you very much. You can put your hands down now. My name is Ginny Fitzpatrick, and I am your presenter for the next hour. What our plans are is to give you enough information about artificial intelligence. That way you can understand some of the buzzwords and a few of the major concepts. What I am going to do to get started here is to get the slide presentation going. So hang on a second and let me make that happen. Okay. All right, so our topic is artificial intelligence for managers. And what our plan is to spend, from a timetable, I'm hoping to spend about 30 minutes on concepts in architecture and discussion, which is what we've got here on the slides. Then do about 20 minutes of live demos. I've got the 4 major vendors all queued up to do some demos for you to see comparisons between them. And then maybe leave about 10 minutes at the end for questions and answers. We do have the QA window open. I have it open here on my screen. So if questions do come in as we move through, I'll try and keep my eyes on the screen. If I do get distracted and I'm not paying attention, you can try raising your hand as well. So our topics for the lecture portion, the first half hour, is just some introductory information. What is artificial intelligence? You'll hear it called AI. What is a neural network and why is it important? What is machine learning? What is natural language processing? Again, the acronym you'll hear for that is NLP. What's a typical project life cycle look like? And then we'll move into the demonstrations. Before we start, let me just give you a little bit of background on myself. I have been working with AI for about 2 years, mostly in the software as a service area, using the major vendors to use their artificial intelligence tooling to apply to different applications. I've got a lot of other backgrounds in other different areas. I work very heavily in the middleware stack with server architecture, server performance tuning. Also, I do a number of development classes and modeling and process flow classes. So let's get started now with artificial intelligence. So just the general definition, at the most general level, any attempt to simulate human thinking would be considered artificial intelligence. So what we see here is we're going to be looking at what are some of the different toolings and what's the technology that has made it such a hot topic right now from the standpoint of how we can get this artificial intelligence to work in our environment. Now, when we think about artificial intelligence, we've talked about it being an alternative to human learning. Let's just take a little bit of time thinking about the concepts of human learning, and that's not what I wanted to share. Here we go, back to the right screen here. So we can break human learning down into 5 steps. First of all, observing the environment as it's presented to us, and we use our senses, sight, touch, smell, taste, and air for that. Once we've assessed that, we then draw on our past knowledge to kind of assess the current situation. We'll observe, we'll consider what to do next. We'll generate a hypothesis on how to react to the current environment based on our knowledge of the environment. We'll very quickly in our mind go through the benefits and the drawbacks of all of the different possibilities. We will then make a decision and decide which path of action is the best next action. Now, that sounds like a lot of steps, but let's think about it in a very simple environment. Here we've got a picture of an elevator, and next to the elevator are the steps. And perhaps I'm standing there in the lobby and I need to get to the 5th floor. You know, that concept of observe, I observe an elevator, I observe the alternative steps. I hypothesize, I think about going into the elevator and pushing a button, how nice that's going to be. I also think about walking up 5 flights of stairs and decide that's not something I'm really excited about. I go through my evaluation process that for me, the best choice for 5 flights is to push the button. Therefore, I make my decision and I step into the elevator. Those steps, observe, hypothesize, evaluate, decide, that is exactly what our cognitive system, our AI, artificial intelligence system, is going to go through as it tries to make a decision. And this is the foundations of artificial intelligence. Now, AI is everywhere, and you probably use it very often without even realizing it. Things like duplicate data detection, spam detection routines, reverse image searches. That's where you might have a repository of 1,000 photos, and you say, I need a photo of a man in a suit presenting on a whiteboard, a reverse image search. A recommendation engines, people who bought this also bought that. And auto correction systems, those are all based on artificial intelligence technologies. Now, the tooling that's out there, the technologies, is a vast number of different choices. And these are some terms that you'll hear that are all related to artificial intelligence. Deep learning, and that refers to the deep hidden layers of neural networks. And we've got some slides coming up on that. Robotics, which is robotic process automation. This is where you think about it as automated cut and paste. Someone sends you an email with a list of 5 products and prices, and those entries have to get entered into a computer system of some type. You're most likely going to open 2 windows and cut and paste. Well, we can have that done automatically with robotic process automation. Natural language processing, the ability for the computer to understand written text. Assisted classification, looking at 1,000 documents and saying, here's the 5 categories, divide those documents up into those categories. Big data, looking at terabytes of data and asking the system to go and find patterns and trends. Bot frameworks, we've all tangled with chatbots out there. They're all over the place. And again, this is the automated version of the chatbot, which is the computer-based one. And then it would most likely have some sort of triggers that would transfer you to a live person when necessary. Neural networks, this is the concept of how the computer is trying to simulate the way your brain works. Cognitive modeling, any ability to work with tooling that's human-based, trying to get the system to solve a problem as a human would solve a problem. Back to those steps we looked at to evaluate, to hypothesize, and to make a decision. Speech recognition, speech to text, text to speech. Self-learning, one of the most interesting things about artificial intelligence is that these systems teach themselves. Most computer systems, when you install them, they depreciate over time. An artificial intelligence system is going to appreciate over time because it will become smarter the more you use it. Prediction, predicting and forecasting. Semantic reasoning, allowing the system to understand the meaning and the concepts beyond just the words. And we all know that there's lots of times when you're looking at a word and it could mean several different things. The semantic reasoning is going to help it figure that out. Image analysis, looking at a picture and deciding what it is. And collaborative networks, having a variety of entities, working together. Now, let's move into the concept of a neural network. So typical data mining systems, as we've known them historically, use standard algorithmic, and let me get a highlighter here, use standard algorithmic linear approach to processing. Works great for calculating a spreadsheet or searching through a database, not very effective when it comes to trying to simulate human thought. So a neural network is a more modern approach for implementing AI, and they try and emulate the manner in which a brain works. How does the brain work? How does it learn? How does it decide? Now, neural networks are very effective, especially when trends are too subtle or complex to be seen by the human eye. We as humans have amazing capabilities, but if you asked us to look at 1 million documents and find a pattern or a trend, that's not something we're good at. The system also needs to adapt dynamically over time. You may have a situation where it's going to come up with one set of thoughts, But as situations change, then the answer is going to change. Just like a human, it's a simple thing. You know, as the weather changes, we're going to change our clothing. Well, it has to be adaptive and be able to pick up and sense the changes and respond to the changes. Also, the neural network has to be able to process in real time. You want a system, not only is it going to be able to look at a million historic documents, but maybe it has to look at 50,000 transactions an hour as they come in live and update the analysis as it does that. So these are capabilities that we see in neural networks. Now, trying to simplify a neural network, we could put an entire class just together on what a neural network is. But just some brief points here. It works with multiple input streams. So there's different components that are feeding data into the network. These components have weights assigned to them based on importance or variables defining what that input is. The neural network then calculates the sum of the inputs, and it will generate conclusions based on a threshold of confidence. And perhaps you're going to put some restrictions in there and say, only give me an answer if you're 80% sure it's the right answer. You know, if you're only 75% sure, that's not appropriate for me. Right, and again, think about how this applies to how we think about something. You know, we have a decision to make, and maybe it's as simple as we're backing out of the driveway. You know, we look at a lot of different inputs. We put different levels of weight on the different inputs. We organize them in our mind and we decide, yes, it's okay to back up. Right? That's what a neural network is trying to accomplish for us. Now, this is a simple diagram of a neural network, and the reason I put this in here was because of a couple of phrases that were on the previous slides. Takes all of the input, and if you notice this in this diagram here, in my input layer, there's 4 circles, 4 inputs. And I want to point out that each input goes to every node in the second layer. Right? And then the second observation sends input to every node, and the third one sends input to every node. And then this hidden layer, this is where all those weights and biases are. You know, the hidden layer says, well, okay, you've given me 4 pieces of information, 2 of them are important, 2 of them are not important, and it goes through its own calculations and it finally comes with the output. All right, now in this diagram, there's only one hidden layer. In a complex environment, there may be multiple hidden layers. There also may be much more input than what we see here. So this is the classic neural network diagram that you'll see, and you'll see different levels of sophistication with how many input nodes they have and how many hidden layers they have. But they will all have this concept of every node passing to every node in the second layer. Now, where do we see these neural networks applied? Pattern recognition, system monitoring, chaotic forecasting. Those are all good examples where neural networks will be very successful. We can then take these techniques and apply them to financial analysis, sales predictions, market research, investment analysis. So you'll hear the term deep learning. Well, that comes from these deep layers of nodes in the neural networks. Now, the next topic we're going to look at is machine learning. All right, and again, a lot of people group artificial intelligence and machine learning together. You need machine learning to do artificial intelligence, all right, but they're 2 separate things. So I have a definition here. Machine learning is a field of artificial intelligence. So it's basically a subset of artificial intelligence that uses statistical techniques to give computer systems the ability to learn from data without being explicitly programmed. The name machine learning was coined in 1959 by Arthur Samuel. Now, when I pulled this definition from Wikipedia, I said, well, okay, I need to know more. So I looked up Arthur Samuel, and he actually wrote the first self-learning program. And it was a checkers game, you know, and if you were to look it up, it's the Samuel Checkers Player Program. And the more checkers that was played by the computer, the better it became at learning how to win at checkers. So he started his career at Bell Labs and then worked for IBM and then was a professor at Stanford University for a number of years. Now, in machine learning, we obviously now have a machine that's trying to learn and improve over time. There are 3 different types of learning methodologies: supervised, unsupervised, and reinforcement, and we're going to review each one of those. So supervised learning, as the name would imply, is training data with known inputs and expected outputs. It's basically giving the computer the problem and the answer. That way it sees examples of what it has to deal with. Given this information, the computer will generate an inferred function or an algorithm. The more training data you give it, the more precise the algorithm would be. That inferred function is going to map whatever input you provide to what the expected output is. And one more point beyond supervised learning, it's not just giving it all of this data with the answers for it to learn from, it's having a technique to apply error correction to improve the results. So if you feed in 1,000 documents and then you give it 10 test documents and it gets one wrong, you can correct it so it knows, all right, I made a mistake, I won't do that again. It's the concept of supervised learning. Now, unsupervised learning is, again, as the title is, there's no external input, there's no teacher, there's no answers being given in advance. The conclusions are based solely on the data the system recognizes. It'll look at 1,000 documents, it'll learn about what type of data is in the documents, and it will generate the categories or the classifications that it feels are appropriate. You'll hear this term self-organizing or clustered. It's going to look at all the content, all of the documents, cluster them by what it believes are related documents. It's looking for collective properties that emerge just based on the type of information in the documents. All right, and this is unsupervised learning. Unsupervised learning is perfect if you've got a body of content that you don't know anything about. All right, you can't do supervised learning and tell it what the categories are if you have no idea what's in the content. A great example of using unsupervised learning might be if you have an employee, let's say this employee is retiring and they have 20 years of their emails in their email file. And on their last day, they say as they leave, you know, you really shouldn't delete that file. There's a lot of important stuff in there. Well, great, who wants to go and read that? But if you were to pass that through unsupervised learning, you're going to see it self-categorize and cluster all of those emails. And for example, maybe there's 500 emails on a vendor contract that was initiated 5 years ago, and that vendor contract is up for renewal. It would be beneficial to know that there are those historic documents there if they're needed for anything. Now, the third type is reinforcement learning, and this is where the learning tries to learn through trial and error. So reinforcement employs a rewards-based system. You know, it's going to monitor the various results and it's going to adjust based on how the actions impact the rewards. Under the hood, it's almost like a dollar bonus type system. You know, if I get to the answer and it took me $100 to get that answer, I want to try and get the same answer for second time. Maybe it's going to cost me $90, and the third time maybe $80, and the 500th time it's going to cost me $45, and it's never going to go lower than that, but it's just learning and getting more efficient. A good analogy to this would be to think of a child playing a video game. You know, the reward is the score at the end, and they keep trying to get a better, faster score. That would be reinforcement learning. Now, I do want to stress, because it's an important concept to grasp, clustering versus classified. Supervised systems are grouping data according to predefined labels. It's your content, and you say this should be divided up into, I don't know, HR and production and project management and payroll. All right, you are classifying it, so it's known as classification. Unsupervised learning, where you do not give it any categories in advance, it's simply looking at and grouping it. This is known as clustering. And clustering is very important when we start working with image and character recognition, and we will see some demos of that when we do the demos at the end of the session. Now, we're obviously training a system, and we're talking about how it's going to learn over time, but we are spending money on this. We have someone in our organization asking us, well, is it working? So we need ways of measuring quality. So how would you know if your machine learning solution is working effectively? Well, we can get some performance indicators. There are specific formulas to measure accuracy, precision. Based on the results of that, we could then do additional training. So if we feel the accuracy is low, we might add more training data to try and increase the accuracy statistics. All right, and based on all of this, you'd also have to make sure that there's no biases or self-validation, that there are there's no content in there that's getting interpreted incorrectly. So there's things that you can do to measure that and see how successful it is. So I'm going to go through with you the three most popular formulas for measuring the quality of your machine learning, and they're precision, recall, and accuracy. Now, these diagrams work really well to get the point across. Precision is the documents labeled positive that are actually positive. So if we look at this diagram here, we can see, and the way it works is I have negatives on the right and I have positives on the left. And you can see inside the circle, this area right here, these are my true positives. All right, so as I asked the system to classify this, well, it looks like there were a lot of positives, but he only got 5 of them out of the total 12 positives right. So to calculate this, I would say true positives divided by the sum of the true positives plus the false positives. All right, and when I do that calculation, in here I can see there were 3 false positives, meaning 3 negatives that I called positive by accident. So I have a total of 8 positives, but only 5 of them were true. So that gives me a precision factor of about 60%. Now, the next formula is recall, the percentage of documents labeled as positive that were retrieved. All right, so here I'm working with just the positive side of it over here. So I am doing a calculation that's going to be my true positives divided by all of the possible positives, which are the ones I really called positive, as well as the ones that I called negative that were really positive. And in this particular example, if I had added that up, I would get, 5 positive over a bank of 12 that are actually positive. So I would get something like 40% recall. Now, the last calculation to look at as an indicator is accuracy, percentage of documents that were correctly labeled. All right, and this is a simple formula. It's all of your positives that you got right, true positives, all of the negatives that you got right, true negatives, over the total document count. So let's say that there were 100 documents, right, and I got 50 true positives and 20 true negatives. Well, I got 70 correct out of a total of 100. I would be at a 70% accuracy. All right, so now I may have more sophisticated formulas. I may need to weight certain calculations. So I may say that, well, there's certain elements out there that were harder to get correct. Therefore, if they got them correct, I'm going to weigh them a little more. So there's a lot that you can do with mathematics to perfect your accuracy formula. But at the simplest formula state, it's everything you got right over the total number of documents. Now, our last concept to take a look at is NLP, natural language processing. And this is the ability of a computer program to understand human language as it is spoken. All right, so when we say NLP, it's a very important component of artificial intelligence. Think of your Alexas and your Cortinas and all of the different technologies that are out there. You know, first we're speaking to it, so it has to do the speech to text analysis. Then it has to go through that text and understand what is that text referring to. So if we look at the data in the world, our new cognitive systems need to be able to handle unstructured data. About 80% of the data in the world is structured. The rest of it, I'm sorry, the other way around, 80% is unstructured. Newspapers, blogs, audio transcripts, tweets. And this unstructured data could be very difficult to work with, ambiguous, complex, difficult to process. Structured data, that's the other 20%. All right, and structured data is what our computers have been working with for years. Databases, spreadsheets, metadata, organized, structured, well-defined schema, easy to go in and get access to. But this is what we want to spend our time with. We want to get our hands on and understand that unstructured data. So how does NLP actually make this happen? All right, the key is for ingesting unstructured data, the NLP system must understand the grammar, the culture, and the context of how something is used. Your system is going to learn just like a child learns how to speak a language. All right, they're going to learn utterances, they're going to learn phrases. All right, it has to understand the data meaning. It has to read and interpret it grammatically, so it knows this is a sentence, this is a subject, this is the predicate, this is the verb, these are adjectives. It needs to understand it relationally. You know, I simply made a statement about machine learning and artificial intelligence. Are they related? Structurally, understanding the sentence structure and then understanding the semantics, because a phrase might mean something differently based on how it's used. What other words are around it? It will give the computer a hint as to how this should be used. Now, this diagram here just talks a little bit about the types of steps that the NLP process goes through. There is a term you'll hear, it's called the pipeline. You know, your content, your input comes in at one end and it goes through a pipeline, and the pipeline rips the text apart until finally at the end it has an understanding of it. So these are just some of the core features that a pipeline would include. First of all, the lexical. This is simply parts of speech. Where are the nouns? Where are the verbs? Where are the adjectives? Are there any adverbs? Are there double negatives? It looks at the parts of speech and it literally throws out unnecessary or and, or, nor, if, you know, things that aren't going to be important to the understanding of it. Next, it goes through the syntactical. This is understanding the subject, predicate, verb, who is being acted on, what is the action item. Think back to high school English where you had to diagram a sentence. That's what this is doing. Then semantic, the meaning of the vocabulary as it is used conceptually. For example, the word broke. You know, I broke a record, meaning I went through a fast time. It's a record, versus I broke my leg, right? The same word, but two different meanings, all right? The semantic has to figure that out. And then the pragmatic, you know, this is where we're making assumptions based on what we know. For example, I could tell you I live in New Jersey, and the fact that I live in New Jersey gives you a piece of information that I live in the US. I didn't say I lived in the US, I said I live in New Jersey, but they're given, or the understood is that because of that I live in the US. Now, just to add one more point on this, any of the vendors that are out there, they're going to understand and put all of this together for you. If you work for a chemical company and your documents have very long, complicated chemical terms in it, the system is not going to understand that. So you would need to add to your pipeline your own unique dictionaries, your own unique annotations to help the system understand how to interpret your unique vocabulary. And there's wonderful tooling out there to help you do that. Now, what can we do with NLP? Well, we talked about all that great document classification. Obviously, it needs to be able to read the text and understand it to do that. Sentiment analysis. You could actually have it read a block or a paragraph or an essay and have it analyze the sentiment and the emotions and the context of that document. Questions and answers. You can have the system, this is how our chatbots are working. You would ask it a question, it will basically understand the utterance that you are passing, interpret what the intent is, and then go and look in the repository of research that's available to come back with related documents. That's how our chatbots are working. You know, it'll understand what your intent is. Your intent is to make a dinner reservation, and therefore it will then prompt you for what it needs to know in order to do that successfully. Your speech synthesis, speech to text, text to speech, and that concept of understanding and also speaking. Not only can it speak, but it can speak with emotion. All right, so there's amazing technology, and we'll see some demos of that in a few minutes. Now, what's your typical project life cycle? Well, everything is based on data. So first of all, you identify the data, and then you have to prepare the data. A big part of working with machine learning and artificial intelligence is making sure the data is clean. You need to get rid of duplicates. You need to get rid of data that's not at all related to it. And that's not an easy job, but there's tooling out there to help you do that. Select your type of machine learning, supervised, unsupervised, reinforcement. Usually you would start with unsupervised just to get an idea of what you have, and then refine it with supervised. Go through the training. Training is an important piece. You need lots of data to train. If you had, for example, 1,000 documents where here was the document and you knew the category you want that classified by, you would most likely train it with maybe 800 of those documents, reserving 200 documents that you knew the answers for the testing. That way, when you actually tested it, you knew for a fact, well, it said it was true and it is true, or it said it was false, but this is really true, so you can do your statistics. You then evaluate your precision, your accuracy, your recall. If everything is good, you deploy it into your production environment. And on an ongoing basis, you assess and adjust. Keep your eyes on the accuracy, the precision, and the recall, because it may need to be tuned and trained as the project lifecycle moves through. Now, you can actually go out there and get machine learning libraries, write Python code, and make this all work. But the more successful route is to work with vendor tooling to eliminate custom coding. The major vendors that have very attractive offerings out there, and these are in alphabetical order, and that's how we're going to be looking at them: Amazon, Google, IBM, and Microsoft. They are all offering machine learning technologies and artificial intelligence services with software as a service. So it's a pay-as-you-go environment. So at this point, we're going to transition into the demonstrations. We're going to look at those 4 major vendors. I'm going to show you just the dashboard screen for each of the vendors so you can get an idea how they present their artificial intelligence tooling. And then what I've prepared is a collection of files. We're going to do a visual recognition. I've got an image and a piece of text, and we're going to try it in all 4 different vendors. That way you can see how they each would analyze the exact same photos. We'll then move into natural language processing, and we'll do some work with speech, tone, understanding the chatbots. And I do have some screenshots of Python machine learning libraries. I actually think I will show you those first, because once we get into the demos, it tends to just go in a lot of different directions. And I do want you to see what the hard coding would look like. So I do have a screenshot of that here at the end. Okay, so if you are a Python programmer, here is a very simple application that you can see is calling the machine learning libraries for k-means distribution. All right, then it's grabbing an input file, and then we're asking it to predict the data in that file, and we're asking it to find the cluster centers for us. And the results are, you can see, this is when we chart the data we pass to it. It's kind of obvious that I've got these 3 clusters of data. And the programmatic results that came back gave me the ranges of those 3 areas. All right, so again, you can program this directly. However, most people would prefer to use vendor tooling with some nice drag and drop functionality instead of actually working with the program code. Now, let's go back and transition into the demo at this point. One more slide back. And I'm going to switch. Let's see if I can do this gracefully. I'm going to switch to my browser. And we are going to start with Amazon. I'm trying to go in alphabetical order, showing no favorites here. So, and I am logged in as myself. It may challenge me to log in again because it has been maybe 45 minutes since I logged in. But you can see here, in this case, you can see what I've been working on. I've been working on visual recognition and machine learning, my favorites. And then if I scroll down here, I can see this area where all the machine learning information is available. If I now take a look at Google, this is, again, I'm logged in with Google. If I come over to the end, I can see down on the lower left, let's see how I can scroll down here. Got a lot of stuff on my screen. Here I can see an entity for artificial intelligence, machine learning, natural language processing, translations, visions, they're all down there. IBM Watson, and I have done the bulk of my work on the IBM Watson platform. I teach a number of artificial intelligence classes for IBM. We can see here conversation, discovery, visual recognition. There are 14 artificial intelligence services that are all out there. Now, everything I'm showing you is able to be done for free. You do have to register an ID and log in, but they are free. Certain ones are free for a year, certain ones are free for a month. They each have different plans. Many of them, after the free is over, they give you some sort of a credit. That way you can continue practicing with their money instead of yours. When you go live with production, that's when the clock would start. And then if we look at the Microsoft, and let's see, I believe this one is Microsoft. Nope, that one is not Microsoft. Hang on a second. This one is Microsoft. And I am wondering if I am still sharing. Attendees. Stop video. Am I sharing, Alex, or did I lose the share?
You're just showing your webcam.
Okay.
We cannot see the screen.
I hear you, and I am how about now? You good?
Yep.
Okay. I accidentally, when I was trying to close the window, I closed the share, I think. All right, this is Microsoft. All right, so now if I come over and look at Microsoft Azure and hit all services, their services are in alphabetical order. And if I scroll and I look for the M's, here's all my machine learning services that I could see available. So what I'm going to do now is I've got 2 pictures that I am going to show you, and I will show you each of the pictures on each of the vendors, just so you can see the comparison between them. And I'm just going to work from left to right on my screen. So if I go to Watson and I go to Visual Recognition Demo, I see that it has the ability to come up and pop up information. I am going to go and find one of my own photos. And so we're going to do this cute little girl with a hat who happens to be my granddaughter. And we can see that it has, and I want to close this window. You can see that over here it's come up, it's figured out that there's a hat, it's called it a beret, a pillbox, etc. If I come down here to the face model, it's specifying age 6 to 12 female. It's telling me, well, there's no food, and they also have the explicit model, you know, is there anything offensive in this? And it's saying there's nothing offensive. All right, now that's how the information is coming back. This isn't a very attractive web page, but it actually would return a JSON file that I would then use in my application. Now I'm also going to pass, and I'm going to use the same 2 pictures on each vendor, text, handwritten text. All right, so I made a little shopping list here: eggs, milk, bread, butter, OJ, and it's thinking about it. All right, and it's coming back and it's giving me some description about what I have there, but it's not doing much from the standpoint of text. There is, the text model is in beta on IBM, and you see it came back here with no results. I mean, that's on the handwritten. If I had put like a sign or a typed document, it's able to do the typed, but it's not at this point doing the handwritten. Let's move now to Amazon. And if I go to Amazon Web Service Recognition, and I'm going to try the demo. And again, you don't even need an ID to try these demos. You could just Google Amazon Web Service demo and you would get to this screen. So I'm going to upload the same 2 files. So I'm going to get first the little girl so you could see the results coming back. And again, the same thing: clothing, apparel, human, beanie, cap, bonnet. All right, so it has done that all for me. And here I would actually see the request and the response. If I drill down into the response, that's what that JSON return would come back. And you see it is acknowledging that it is a person. Somewhere in here, it said person. All right, now let's do text. Object in scene. So we're going to get that same message. All right, and it is determining that it's text, that it's handwritten. And if we go into the response, it's not showing me much here from details of it. It's acknowledging that it's text or it's handwritten, but it's not. Now, if I come over on the left, notice it's looking for text in an image. Let's try that same upload here. And look at this: eggs, milk, bread, butter, OJ. Perfect. All right, really well done. Now let's go to Microsoft. And did I do it again? I did it again. Here we are, Microsoft Azure. And again, they have different sections for different parts. We'll do the image first. All right, and again, coming back with the description, with the tags, notice it's got the confidence level in here. So for the features, if I scroll down on this, age 4, female, rectangular face, gray, black. So it really did a nice job there. Now I'm going to scroll down. There is a second area for handwriting testing. So I will browse for my shopping list. All right, and we can see there, again, did an excellent job. Eggs, milk, bread, butter, OJ. So really worked very well there. All right, what I'd like to do now is just jump back to the IBM tooling and just show you a few of the other different tools for the NLP, the natural language processing. So we'll start with discovery. And again, I'm just jumping into the demos. All of these are available for free. You don't have to even log in to see some of the demos. And you basically will just type in something you're interested in investigating, and then it will look it up and look at press releases, whatever. So I am going to look at www.ibm.com, since I'm on the IBM site. And what it's doing is it's doing a search, and I guess I didn't specify here. Let's just go 2 weeks. It's doing a search to search all of the media that is available based on that company. And it's coming back with top stories, top entities. Again, this whole Linux acquisition is out there. Sentiment analysis, you know, looks like IBM's got 83% positive, 15% negative. Then it's looking at, these are all sites that it pulled that had references to IBM. And you can see it's giving you the positive versus negative tone of what's being said about IBM on those sites. Some statistics, number of mentions, positive versus negative. This is probably when that announcement was made. And then just other information here. We can see, you know, relationships between IBM and Oracle, between IBM and Google, and obviously IBM and Red Hat. All right, and this is just software as a service. Use this tool to help you when you're making a business decision. You know, you have a meeting with company ABC tomorrow. This would be the place to go to find out some quick information on that. Now, let's take a look at the natural language understanding, where it's converting the speech to understand it. So they have some text here in which they're going to take a look and give you an analysis of it. But what I'm going to do is I'm actually going to pull some text. So I'm going to just wipe out the text that they have there. All right, come on, let's delete the text. And I've got a couple of documents. What I did was I just went out to Amazon and looked for some, I just Googled essays to analyze. So I've got a couple of documents out here. So let's see, you know, GMO, genetically modified. I'm just going to grab that text. And put that into here and analyze it. All right, so here we can see sentiment, emotion, the levels of emotion, keywords that were picked up out of that document. Remember we talked about unsupervised learning, let it go look and let it categorize. Well, it figured out these were important keywords coming out of it. Entities, any known, again, the system is trained. This is what you're paying for with the service. It has already been trained. Cities, states, landmarks, points of interest, popular people. Categories, decide what categories, and notice the hierarchical category. Concepts, genetic engineering, and the semantic roles. You see, again, relationships between them. All right, so very interesting the way it puts all of that together. Let's look at the tone analyzer or the personality insights. I'm going to do the tone analyzer. And I'm going to actually analyze one of those documents that I had was a press release, or actually duties and responsibilities email. You know, perhaps you're writing an email to an employee and you need to kind of lay out, this is what I need you to do from this point forward. It might be a good idea to pass that through a tone analyzer before you actually send the email to see the tone. I've actually started using this, you know, as I write documents. You notice it's pointing out joy and analytical. All right, and then if I come down here, you know, and I look for analytical, you know, it's actually pointing out, see my color-coded references, you know, what lines in the text represented joy and analytics. Over here, confidence, we should be able to see some purple. There's, you know, the phrase that represented confidence level. Joy, you know, there's the joy, and tentative. This is where you could find. So maybe you didn't want to appear tentative. You could go in there, and I guess it would be farther down. Oh, tentative, there it is. You might want to reword that and then try again. Again, something that's really handy. It's out there and it's available. If I take that same document, that was tone analyzer. Let's now look at personality insight. And I am going to do my own body of text. And I'm going to put my text here. And I'm going to analyze it. All right, and this is the personality portrait. You know, analytical, energetic, motivated to seek out experiences, things you might be likely interested in, you're unlikely to do. And then down here, all of the traits highlighted for you. All right, very interesting. If we think about this personality portrait, let's say that you're hiring and you've got 500 resumes that came in electronically. Figure out what traits you're looking for, pass it through this personality analyst, and let it come back with, you know, the 50 resumes that scored highest on the traits you're interested in. And read those 50 resumes instead of reading all 500 resumes. All right, I do want to leave time for questions. I did not show you the speech to text or the text to speech, but let me just check the questions. And if there are questions there, we'll answer those first, and then we can do the speech to text and text to speech demos. So let me just look at, I see 4 questions. Okay, a couple of them. Were you going to show the Google demo? I believe I did that second. What trends am I seeing in AI? I am seeing that everybody is interested in it. I have seen major corporations put a tremendous amount of dollars into bringing on board teams of high-end people to understand it and use it effectively. I think a lot of people are concerned about letting it go and having it give bad advice. So the interest in analyzing precision and accuracy and success is very high. I think we're on the early stages of it, but it's going to be there and it's going to be everywhere. So getting involved now is the right thing. Let's see, I have Rashmi. Do you have a question? Do you want to type that in? Yes, I could. I do have the links to the demo pages, and I will get them to Alex, and Alex will make sure that they get out to the participant list. All right, where can I learn more about analytics, or how should I develop my skill set? The analytics side is very interesting, and there's a lot of free tutorials out there to get started from a machine learning, get exposure to it. I think you need to, from the standpoint of perfecting it, you would need to determine Are you going to be using a vendor? Which vendor are you going to be using? And then look towards that vendor for what they have available for analytics. I know that WebAge has a number of analytics courses that are out there, but again, deciding on which vendor you're using might affect which course is going to be more suitable to you. For myself, again, I started working with machine learning and artificial intelligence about 2 years ago, and most of what I got was self-taught from the beginning, just understanding the concepts. My background is mathematics, so it kind of pointed me in the right direction. And then I started experimenting with what the vendors had available, and as you can see, there's some nice choices out there. Would such systems be called ML models or AI systems? Excellent question. I think the concept of AI is understanding the question we were just asking, analytics. It's understanding analytics as well as machine learning. I could have an artificial intelligence system that's looking at transactions of sales data. It's not using machine learning because it's looking at structured data, but that would still be considered artificial intelligence. When my artificial intelligence is trying to work with understanding the written word and text, that's where I am applying machine learning to my artificial intelligence. All right, let's see. Where can we find more information about AI, books, development, overview? There's a lot of material out there. I don't know if you can see the camera, even simple things like machine learning for dummies has great information. There's a wealth of information just out there on websites as research material. Interesting enough, I tend to buy a lot of books when I'm working with a new product. I did not buy a lot of artificial intelligence books because there was so much out there available for free. The ones that I did buy, I bought a lot of books on the concept of text analysis, the machine learning piece, and mainly because it goes into the mathematics under the hood that's being worked with. Not necessarily something you need to understand to use it, but because of my mathematics background, it was of interest to me. So I've got a stack of formula books that you probably don't need, but are available. Let's see, next. In the neural network, the hidden layer has different classifiers that has different probabilities. Do humans decide the factors that are important, or does the machine decide? Interesting question. In most cases, the machine decides. So you can make a decision as to what your success level is going to be. Like, I want my success level to be 70% or higher, and don't give me the answer unless it's higher. But you do not go in to those individual nodes and adjust the weights. The weights are adjusted by the system. Right, and that's an example of one of the books that I bought to understand what's actually happening inside that neural network, because it's basically like a black box. The data goes in and the answer comes out, and to understand what's really happening inside there is some pretty complex math, and it is all controlled by the system. Let's see, datacamp.com, learning more of this data science. I am not familiar with datacamp.com. However, I know that when I start getting out and Googling machine learning or artificial intelligence, I could sit at that computer for days. It's just a wealth of information out there. What type of roles are out there in AI and machine learning? An interesting question and a good question, because there are a lot of roles out there, and those roles go anywhere from a business analyst all the way up to a PhD in, artificial intelligence or neuron networks. Typically, a team that a company would put together would be a mix of skills. It would be, yes, you do have to have a couple of high-end people that know what this is about and can validate and assure that you've got a valid, but you need a lot of other people And the skills they bring to the table is that they understand the business and they're able to take advantage of the trends that the machine learning and the artificial intelligence is passing. All right, so there are a wide spread of roles from very high end to your classic business analyst role. Could I elaborate on the NLP processing steps, particularly the lexical? We are actually out of time, but you know, there is a one-day class that's going to give you a little bit more than what you saw here. But the actual NLP processing steps, that's something that you would probably get into. And what you would want to look at is what's called the UEMA pipeline, the Universal Industry. Again, I don't know what the full acronym off the top of my head is for, but there's plenty of documentation, and it's really just the NLP pipeline processing. That's what you would want to look at to understand what those steps are. Text analytics and NLP, free version of Distill. I'm not quite sure what we're looking for in that. What's the job title for machine learning? You know, again, I've seen it all over the place. Very often you'll see job descriptions that are looking for someone to join a machine learning team or an artificial intelligence team. So when I have seen job descriptions out there, again, they're kind of describing the responsibilities, not necessarily putting a title out there. Which programming language is more efficient, R or Python? What should a beginner choose? Probably, I couldn't tell you which one is more efficient. I do think Python is the most popular. R tends to be what we use when we're working with analytics, and Python when we're working with text. However, I believe they both could be used in either fashion. What is my info? And links. All right, and I will make sure that the links get out there. I'm going to defer to Alex now, as we are kind of at our window. Alex, any comments?
Not all good. Thank you.
All right. I think I have a few more slides. Let's make sure I don't skip what I was supposed to show you at the end. We obviously just ran through the questions. I will get those links, and Alex, I'll get those to you, and you can package them up with the presentation when you send that out. We do have the full day version of this coming up on December 3rd. It is a virtual class. So what you had today was about 20 slides of I don't know, a 150 slide deck of the full day class. And here's the contact information for WebAge Solutions if you have any additional questions. All right, I'm going to stop the share at this point and bring us back to the classroom. And let's see, I went through the questions. I do see a few things in chat that I will try and wrap up before we shut down. Yeah, I see comments out here. Again, people are looking for, you know, recommendations on getting more information. Again, there's a lot out there. Even if you just, I'm serious, if you just go to Google and say, how do I get up to speed with machine learning? You'll have a wealth of resources out there. Some of them free, some of them fee-based. I do see how to get into the full day class, and Alex can help you with that. As I said, it's coming up on December 3rd. All right, I enjoyed it. I felt like I did all the talking here. You know, this 1 hour is pretty quick. I hope I do see some of you in the virtual class, and I appreciate the opportunity to chat with you. Good luck with artificial intelligence and machine learning. And I will be shutting down now. Thank you.